Okay, for one more review, since we're going to have the test next class, reminder, let's just kind of review some of the things we've learned. Let's start with area. That's easy. We'll get our brains warmed up on a Wednesday. So find the area in the first quadrant enclosed by sine x, cosine x, and the y-axis. So if you wanted to use your calculator to help, you can. I hope we remember that, you know, if we look at sine x, it's going and then blah, 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 and then down and then back up. And we only want the first quadrant, right? And then cosine kind of does the opposite, right? Okay, and then there, and so forth. And then it's going to repeat. But we don't really care about the repeating. Which area are we looking at? Well, between sine, cosine, and the y-axis. So right here. So I really need to know where they're crossing. So you can use your calculator for that. I think I know where it is. When are sine and cosine the same? Isn't that like pi over 4? They're both square root of 2 over 2? Yeah, so that's pi over 4. So from 0 to pi over 4, which one's the top graph? So which one is the one that starts at the top of the hill? That's cosine. Minus our sine, that gives us our height, dx. And you're welcome to do it in a calculator here. So quit alpha f2, the integral from 0 to pi over 4. Oops, I'll put 2 fours. Of cosine x minus sine x dx. That's 0.414. Okay? Find the area between 0 and pi over 2 enclosed by those two and the x-axis. Oh yeah, because right here, isn't that pi over 2? Okay, so this one's a little bit trickier. Okay, so we have cosine. Oops, I don't even care about that part. So cosine is up there. And then this is sine. And this is pi over 2. And this was pi over 4. So where are we really looking at? Well, this part and this part. Well, this is going to be 0 to pi over 4 of sine x. And this is pi over 4 to pi over 2 of cosine x. Now, and that was cosine x. So, integral from 0 to pi over 4 of sine x, plus the integral from pi over 4 to pi over 2 cosine x dx is 0.586. Okay, let's also review some revolutions. The last video I did was reviewing cross-sections. Now we're really going to review those rotations. So if we took y equals x squared, so y equals x squared, 1, 1, 2 goes to 2, 3, 4. Here's my graph. It says bounded by y equals x squared. Here we go. Y equals 0, which is the x-axis, and the line x equals 2. And we're rotating it about the x-axis. So it's going to copy down here. And we're going to get those circles. So our radius of each circle is going to be that x squared minus the line y equals 0. And we're going from 0 to 2. Now, they are circles, so it's pi, the radius squared. Radius is x squared minus 0. So radius squared, and we are going about the x-axis, so it's dx. Now, we could actually do this one by hand. It's pretty easy. 0 to 2 of x to the 4th dx. That's going to be x to the 5th divided by 5. Evaluated from 2 to 0. Well, when I plug in 0, that's 0. So equals 2 to the 5th is 32 fifths pi. Came out pretty nice. The next one, let's see. 1/2 x minus 1. So here's my y-intercept. Up 1 over 2, up 1 over 2. So take that. Y equals 0. Oh, y equals 2. Uh-oh, I haven't even gotten there yet. 1, 2. So up 1 over 2. So here was up 1 over 2. So we're talking about y equals 2 would be here. Here. And we're rotating on the line x equals 0. Okay. So here's my region. And it says to revolve this around the y-axis. Oh, okay. So it's going to turn this way. So we need to do a dy. That means I need to rewrite this in terms of y. So x in terms of y. So that's y plus 1 equals 1/2 x. Multiply by 2. Good. Okay. So when we're doing it with respect to y, we need to know our y values. Well, that's easy. 0 to 2. These are circles. So pi r squared. Well, the radius of each of these is going to be this line minus 0. Oh, that's just 2y plus 2 squared dy. Now for this one, and for the sake of time, let's go ahead and do it in the calculator. So 4, I forgot my pi, 0 to 2, parentheses. Now, for the calculator, I'm going to put an x, dx. 108.909. We're going 3 decimal places. Now the next one is similar. Oh, but it says x equals 1 instead of x equals 0. Okay, so we just graphed this. 1, 2, 3, 4. Okay, so up 1 over 2, up 1 over 2, up 1 over 2. Here was my line. Y equals 0 is here. Y equals 2 is here. But this time it says x equals 1 is another boundary. So my region is this. And if I rotate that around the y-axis, we get this open circle in the middle. So I need to think about the radius. It's the radius of the large circle and the radius of the small circle. So, because if I was actually doing it, pi large circle squared minus pi small circle squared. So I can really do it as pi big R squared minus little r squared. So pi. Okay, so the large radius would be that line minus 0. Okay, so we already found that. That was 2y plus 2 squared. And the little radius, oh, it's just a 1. And that was still from 0 to 2 on my y's. So I could actually just go in there and change that. So let me go ahead and select it, arrow over, and put minus 1. 102.625. Now let's look at some A-B questions. So it says R is a shaded region in the first quadrant enclosed by the graphs y equals e to the negative x squared and y equals 1 minus cosine x and the y-axis. So they shaded it for us. Good. Find the area of that region. Okay, that's easy. As long as we know where they meet. Are we sure that's at 1? I'm not. I need to know where that is. So, I'm going to go into my y equals and clear out what's there. And I'm going to put in e to the negative x squared. And this one's going to be 1 minus cosine x. And I see where they cross, and it looks like 1, but I want to make sure. So when I get to the gas, that's when I go to there to click on it. It's 0.94194408. Now, one thing you could do, just to let you know of a nice little trick, is that's our x value right now, right? And I'm going to be doing a lot with this, so what if I took that x value and stored it as another variable like a? So I'm going to do alpha a. So now, anytime I do alpha a, it's going to pull that number up. I don't have to type it in. That's awesome. So that's the x value of where they're intersecting. So the area would be from 0 to a, and they are okay on your test if you've written a down at the top. You don't have to keep writing it over and over and over. Top line minus bottom line, so that's e to the negative x squared minus 1 minus cosine x dx. Okay. Now, wonderful, in the calculator, I put this one as y1 and this one as y2. So, when I'm going in to put this in my calculator, alpha f2, the integral from 0 to a, okay, here's my shortcut, and then this was y1 minus y2 dx. 0.591. Okay, find the volume generated when the region is revolved around the x-axis. Okay, so this is going to get interesting. When it's revolved around the x-axis, we're going to have a little gap area. You see that? That it's going to have a little opening. So you've got an outer radius, which is our y1, and you've got an inner radius, which is our y2. Okay, so I know that it's going to be from 0 to a, pi r squared. Now we have an outer radius of e to the negative x squared, minus 1 minus cosine x squared dx. Now, I know you know how to put this in the calculator, and for the sake of time, I'm just going to go ahead and keep going. What if we said the region R is the base of a solid, and each cross-section, perpendicular to the x-axis, is a square? Oh, that's even easier. 0 to a, set difference squared. So this is going to be e to the negative x squared minus 1 minus cosine x side squared.